So we're going to go to page 572. All right. We're going to start out with just figuring out our C value. So this graph, we only need to find out our A and our C. We're not going to worry about D and B right now. That'll come in a bit. So we're doing a sine graph. Do they tell us it's a sine graph? Yes, right there. So we know it's a sine graph. Our A value has to be positive, greater than 0. So what's the A value for this function? 4, right? Does everybody agree it's 4? Sure. We go from positive 4 to negative 4. So it'll be max minus min divided by 2. Okay, A value is 4. In all of these questions, A, B, and D are the easy ones to find. C is the trickiest. Why isn't it negative 4? Because we defined it that A has to be greater than 0. All right. We'll do the negative one in a sec because that has implications on the equation. Okay. So A is positive 4. Now we got to figure out the C value. C is what makes everything difficult because C changes depending on whether it's a sine or cosine graph and whether your A value is positive or negative. So that's why there's 4 possible answers for every question. Yeah. All right. So the regular old straight up, haven't done anything to it sine graph looks like this. All right, there's y is equal to sine x. Now, what's the midline of a regular sine graph when you haven't shifted it? It's 0. It's the x-axis. All right, that's the line that splits the graph in half. Okay, look at the origin. What is the graph doing? Is it going up or going down? It's going up. Okay, so when you're trying to find the C value for a sine graph that has an A value that is positive, you go to your midline. So the midline of this graph is still the x-axis because we haven't done anything. And you find the closest part of the graph that is going up. So you have a choice. You either can go there because that part of the graph is rising, or, well, you don't. Well, I guess you could go all the way to here. You go way over to here if you really wanted to. You don't go to these ones because the graph is falling at those points. Does that make sense? Yeah. Okay, so what's the closest one? It's this one. 2 lines over, right? But I need to know the actual shift. So you need to figure out what each line is worth. The easiest way to do that is to find pi on your graph, which is right there. How many lines are there to get to pi? 6. 1, 2, 3, 4, 5, 6, right? So each line is worth pi over 6. 1/6 of pi. That's the easiest way to find out how much each line is worth. Okay? So each line is pi over 6 units. How many units to the right have I gone? 2. So our C value is 2 times pi over 6, which reduces to pi over 3. That's your shift. C is equal to pi over 3. So the equation of this graph is A, which is 4, sine of x minus pi over 3. Is that okay? All right. The one below it is the exact same graph, except now our A value has to be negative. So if the A value is negative, what's the A value? Negative 4. Okay. If your A value is negative, like we talked about with that graph I had up there, if I'm going to sketch negative sine x, here's the regular sine graph up here. All right. If I flip that, because a negative a value will flip it, the graph is going to look like this. Correct? Okay, this is negative sine x graph. What's happening at the midline, at the origin? It's going down. So if you're trying to figure out the equation of this graph, when our a value is negative, you go to the midline. You find the closest part of the graph that is going down. Where is that? It's right there. So that is your shift. How many lines is that? 4. And each line is pi over 6. So it's 4 pi over 6. But because we went left, it has to be negative. So that reduces to negative 2 pi over 3. So the equation would be negative 4 sine x plus 2 pi over 3. That will give you the exact same equation, or same graph, I should say. Is that okay? All right, now we gotta do it with cosine. Same graph again. These are all the same graph in the first page here. Except we're doing a cosine, and our a value is positive. So what's our a value? 4. All right. What does a regular cosine graph look like? What does it start at? It starts at 1. So we start here. Okay. What's at the origin? A max. Okay. So cosine graphs tend to be the easier because you only have to look to see where the max has been shifted. Okay. On a regular cosine graph, positive a value, my max is at the origin. So you find the origin, like the y-axis, sorry. What's the closest maximum? You have a choice between those two. Which one's closer? The one to the right. How many units over is it? 5. So our c value is 5 pi over 6. So the equation is y equals 4 cos x minus 5 pi over 6. Does that make sense? What doesn't make sense about it? What? You're plotting the values of the y. That's why you get a wave function. No. No. All right. Next one. Same graph, cosine. A is negative this time. So what's your a value? A is negative 4. All right. If I take my regular cos graph, this one, and I rewrite it as negative cos of x, what happens to this point right here? It becomes a minimum. So the negative cos graph looks like this. and you have a minimum at the origin. So when you're doing an a value of negative for a cosine graph, you look for the closest minimum, which would be right there, 1 unit to the left. So what is your c value? Negative pi over 6. So I get negative 4 cos x plus pi over 6. That's why you get 4 possible different answers. You actually get an infinite, but you always do the minimum shift. So there's 4 possible answers because you can do sine or cosine, and you can have an a value of positive or negative. I will summarize this at the end of what you're looking for, okay? Is that sort of okay? It's the process. All right, that's A and C. Now we're going to add in B and D. So the next page here. All right, here's our graph. You know we've added a D value because it's not equidistant from the origin. It only goes up to 1 here, and it goes to negative 5 here. So we've shifted the graph up and down. All right? So find C last, because C is the hardest one to figure out. A and D are the easiest because they're 2 formulas. So what's the formula for A, or amplitude? Max minus min over 2. What's my max? What's my min? Over 2, which gives me 3. So your A value is 3. We got 1 mark. We'll come back to period. So we'll do period right now. What's the period of this graph? Okay. What is each line worth? 1, 2, 3 lines to pi. So each line is pi over 3. Count the number of lines between the peaks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the period is 12 pi over 3's, which is 4 pi. There's our period. Period is equal to what over what? To find the b value. So period is equal to, what the, there we go, is equal to 2 pi over b. So what's my b value?
1/2 pi.
Not 1/2 pi, just 1/2, right? Because the pi's will cancel. So your b is 1/2. So we got b. You get a mark for amplitude. You get a mark for b. You get a mark for vertical displacement. The d value. This is your d value. What's the formula for d? Max plus min over 2. So 1 plus negative 5 over 2 is negative 2. You got another mark. Okay, now we got to find C. C is the trickiest. So we're doing a sine graph. Where is it? We're doing a sine graph, and our A value is positive. Okay? So if the A value is positive, and it's a sine graph, you find your midline. Where's my midline? It's whatever your D value is. So you don't have to draw it, but I'll mark it on the graph. So there's our midline. And a sine graph with an A value that's positive, you're looking for what? The nearest up, exactly. So go to your midline at the origin. Where is the nearest up? Boom. It's right there. That's the easiest way. Because this part of the graph is going up. So your C value is negative pi over 3. All right, now you just got to plug it all into the equation, which is y is equal to a sine b x minus c plus d. Our a value is 3. What's our b value? A half. Our c value is
So plus pi over
plus pi over 3, and our d value is negative 2. That's the equation. 3 sine 1/2 x plus pi over 3 minus 2. All right, we got to do it again, except our a value is negative. Everything stays the same except your c. Well, and I guess a would change to negative 3. So you get negative 3 sine. Your b value will stay the same, 1/2. Your d value will stay the same. Negative 2 goes on the outside. Your c value changes. So if a is negative and it's a sine graph, you're looking for the nearest part of the graph that is going down. So there's our midline. Nearest part of the graph that's going down is right there. So how many units is that? 1, 2, 3, 4, 5. So it's going to be, so our c value is 5 pi over 3. So it's x minus 5 pi over 3. So that's the two sine equations. Now we're going to do cosine. But what's the only thing that changes? The c value is the only thing that changes. So what's our amplitude, our a value? 3. We're going to do cosine with a positive a. What's the period or the b value? We'll do the b value. It's a half. It doesn't change. What's the d value? Negative 2. Okay. The c value changes. But for cosine graphs, it's straightforward. If your a value is positive, you're looking for the closest max to the origin. So closest max is right there. It's 2 units to the right, so it's 2 pi over 3. So the equation will be a cos b x minus c plus d. Three cos 1/2 x minus 2 pi over 3 minus 2. That's the cosine function. And what's the last one we have to do? Negative. A value is negative. On a cosine, you're looking for the closest minimum. So there's the minimum right there. So your c value is negative 4 pi over 3. So the equation is then negative 3 cos 1/2 x plus 4 pi over 3 minus 2. All right. Here's your summary. All right. If you're to find C for a sine graph, if A is positive, you're looking for a rising midline, which means it's the part of the graph going up that is closest to the midline. If you're doing A is less than 0, it's a falling midline. It's the part of the graph that's going down. And if you're doing cosine, A is positive, A is negative. What are you doing if A is positive for cosine? Yeah, max, I'll say close. It's the closest max. And if it's less than 0, it's the closest min. So, yeah, you always want they'll say the minimum distance. Whoops. It'll give you the same graph, but they always want to give you the minimum phase shift. So, closest max. So you're looking for that point, and closest min. You're looking for that point. Know those things. Everybody can do all the other ones. These are what determine usually if you're getting full marks or not on these questions. Okay? To the origin. All right, I got one last thing to do. It's pretty short, and then we're done. Page 574, please. Okay, if you have sine and cosine graphs, which parameters, A, B, C, or D, affect the domain? Remember, domain is all your possible x values. None of them do. You affect the domain. You get to decide what the range or the domain is. Yeah. Or I do. Maybe I don't want to give you that responsibility. Why did I write domain again? None. There we go. Okay. Which values affect the range? Range is the possible y values. D is one of them. And A, right? If you do a vertical stretch and then you move it up or down, you're changing the range because it always just oscillates between two y values. What about the amplitude? Sorry, D? It's the A value. What affects the period? B. It's in the formula, right? 2 pi over B. What about what affects the zeros or the x-intercepts? Not everything. There's one that doesn't.
The amplitude does.
The A value doesn't. So everything else does. B, C, and D all affect the x-intercepts. All right. These last things. If you want to find the max and min of a function and you just have the equation, all you need to do is go A plus D and negative A plus D, and that will give you your maxes and your mins. You'll see on Monday that will become useful. So, for example, if I give you this equation here, 3 sine 2 x minus pi minus 4, and I say, what is the maximum or minimum or the range? That is the maximum min. You just go 3 plus negative 4 and negative 3 plus negative 4. 3 plus negative 4 is negative 1. -3 and -4 is -7. So your max is -1 and your min is -7.
Oh, it's negative.
normal sine equation.
What do you mean equation?
Y
I can write those on the board. Like you mean this? Sure, I'll write that on the board.
I'm still very confused.
I know. All right. Here's what you're doing. 3 to 5, 7 to 10. Monday we